Hello there, my name is Khan. Today we'll be talking about OSI, Open Systems Interconnection, or the OSI stack. The OSI stack is very important because today we have the internet. The internet have millions of devices, computers, servers, clients, machines. They're all interconnected, and we access we communicate to the internet through this OSI stack. So OSI is the basis by which we uh, we have this open systems interconnection. The OSI stack defines the 7 layers. Today we'll be looking at some of the features and services that each of these layers provide. And internet is a reality, and because of the internet, all these communicating devices can talk to each other. So we'll be looking at how these applications, how these services, how these communication devices, DC or DTs, talk to each other and how they fit into the world of the OSI stack. So OSI basically defines 7 layers. At the bottom of the layer is the physical layer. The physical layer defines the physical connection, the electrical characteristics of the line. So the voltage levels, the frequency, the clock rate, the frequency, and other important characteristics like how many, what are the connectors like, how many pairs, do we have Ethernet connection, do we have ATM connection, do we have fiber optic, do you have a serial interface, parallel interface. These all define the physical layer of the OSI stack. So it defines the hardware characteristics, the physical electrical characteristics of the line that is needed for us to communicate with each other. And today we have many different devices talking with the different devices all connected to the internet by using the open systems interconnection stack out there. So at the top of the physical layer is the data link layer. The data link layer basically defines the error control or makes sure that we have a clear kind of transmission between two communicating entities. The data that is sent over this link with the data link layer makes sure that the link is error free. It does all the CRC checksums and all the protocol related error correction mechanisms to make sure that we don't have any errors in the line out there. There are many types of protocols that are available. We have HDLC, SDLC, and they define various operations like SABMs, acknowledgements, and data transmission packets that are sent over there. And usually they have there's addresses that are assigned to it. The 822.x type of protocols defines the Ethernet addresses, and various other protocols also define the destination addresses and the source addresses for the communicating devices out there. So on top of the uh, data link layer is the IP routing layer. But before we go into that, we should mention that the data link layer sends all the data that is sent from the upper layers as data in an envelope to the lower layers out there. So all the information from the IP layer and up to application layer, everything is sent as data to in the data link layer to make sure everything is sent in a error-free way. So on the third layer, we have the routing layer on top of the data link layer, and IP is a de facto standard that is used for IP for routing, and the TCP IP is used in the internet as for routing to various devices. So in the data link layer, you might have two devices connected, but in the IP layer, you will have any device that's on the network. It could be multiple devices that are connected, and you might want to send one of them into the network out there. So IP layer also has addresses, destination addresses. For example, IPv4, IPv6 defines the IP addresses for the routing layer, so to speak. Uh, so routing layer is very important in terms of routing your packets or messages, application data to the correct endpoints out there. On top of the routing layer, you have the transport layer. The transport layer, the de facto standard for transport layer is TCP, Transmission Control Protocol. This is used in the internet, and it makes sure that we send data from end-to-end connectivity. So data is sent from one end to another end. It does not care about the intermediate routing points out there, but to make sure from one end to another end the data is sent correctly and without any sort of errors out there. So the transport layer is very important in that sense. There are many transport layer protocols available. TLS, Secure Socket Layer, and TCP are some examples of the secure socket layer. Is basically used to send authenticated information, make sure that everything is encrypted and it is decrypted on the other end when it receives the information out there. So it is very important that we have the transport. The TCP/IP is a de facto standard on the internet that is used. There are other transport layer protocols that you can use, but you can also have routing, X25 routing protocols also that can be used out there. All of that, there is specifications that are available for this type of protocol that can be used for interconnecting on the internet out there. So on top of the transport layer, we have the next layer is the session layer. The session layer, an application can have multiple sessions. For example, you can have an audit session. You can have the message write session or other sessions going on within the application out there. And each session is identified by session ID, and basically on the OSI stack it defines what these sessions are, and the sessions can communicate from one end to the other end, and they fit within the session layer protocol itself. On top of the session layer, we have what we call the presentation layer. Presentation layer worries about or cares about the characteristics of the display, what is displayed out there. So you can have different encoding of data, and all these encodings are specified in the presentation layer. So if one side is IPSIDIC and the other side is ASCII, when the data comes, it is parsed and displayed according to the display characteristics that you have on that layer for that device. So IPSIDIC will be converted to IPSIDIC, ASCII will be converted to ASCII, and then if you're doing HTTP, the various encodings for the different character sets are also included in there. So it would be important for us to know what they are. So on top, so that's the sixth layer. On top of the presentation layer, you have the seventh layer, which is the application layer. This is the topmost layer. The application layer defines the protocol that is going to be used to communicate with the other end. You can have an application, you can have a service, or you can have a communicating device, a DCE, communicating with the other end. And basically we have to make sure that the protocols are specified. For example, you can have a simple mail transfer protocol, or you can have hypertext transfer protocol, or you can have SNMP protocol. These are all application level protocols that are used to communicate with the other side of the entity out there to make sure that the application that you're talking to talks the same protocol or abides by or adheres to the protocol that has been set for that communicating entity. So all these layers are basically used to make sure that we can each device, if they implement the proper protocol at the proper layer, provide certain services, and they can communicate end to end, and they display the various encodings without even though there are different devices, different operating system, different encoding, different hardware characteristics out there. So OSI makes sure that we can communicate from one entity to another entity using all these layers, and everything is all the layers have various protocols that are used to make sure that they serve the purposes, the services or the features that it should perform the functions that are needed to get to the. If there are redundant functions, it might slow things down, but the basic functions need to be performed to make sure that we have an open systems interconnection. So this is how the internet is set up. We have TCP/IP, which is a de facto standard. It is used in the internet to make sure that we have end-to-end connection, and we can serve web pages, and we can access websites using various routing protocols and the transport protocols that we have. And these are important features to make sure that we can communicate end to end in an open fashion. So even if we have diverse devices, we have disparate systems. It makes sure that we are able to communicate, make sure we are able to exchange information, and make sure that we are all interconnected. And this is how everything fits together in the OSI stack, so to speak. So the OSI stack is very, very important if you're talking about the internet, or if you're talking about connecting the internet out there, so about all the different protocols at the different layers. And I've mentioned some of them. I'll go into more detail into each of them, and that will tell you, how what services or features each of these layer provide, and what we mean by the protocols of different layers of there. So that's it for today. Hopefully you can read more about it in the Wikipedia if you need more information about open systems, interconnection, OSI stack for communicating devices. Thank you very much.